Okay, think we're rolling. And it looks like we're ready to review for chapter 6. All right, so I'm going to just rattle off some things here and give you some examples. Some things I don't have time to make a graph for every example, so I'll just tell you what it's like in the review, which problems in the review, and then, yeah, so maybe let me grab a review. And then I can point out specific problems that you can look at so you know kind of what to expect on the test, okay? So, first thing is perpendicular bisectors, okay? What is a perpendicular bisector? Well, you should know that it cuts something in half, cuts it in half at 90 degrees, okay? So this would be a perpendicular bisector. Now, another thing you need to know is that if we connect these endpoints of the perpendicular bisector like this, it must always be true that these are going to be the same length here, okay? So, all right, well, if I told you that this right here was 4x minus 10, and then, I don't know, this was 2x plus 30, okay? Since this is a perpendicular bisector, it's cutting in half and it's a right angle, these two have to be the same because it's right smack dab in the middle. So you could say that 4x minus 10 equals 2x plus 30. Subtract 2x over, we get 2x minus 10 equals 30. Add 10 over, we get 2x equals 40. And then x equals 20. You may be asked to plug it back in to figure out what each of these are. So if I plug it back in, 2 times 20 is 40, plus 30, I get 70. Okay, so if I were to plug it back in, I could say this segment is 70 units long. Okay, so, and another thing you need to know that they meet at the circumcenter. Okay? So yeah, perpendicular bisectors, what are they? They meet at the circumcenter, and you might be asked to set something equal and solve. All right, angle bisectors. So if we have an angle here, and it's being cut in half, like this, just like before, if we pick a point on this angle bisector here, if you make a right angle with that point on the angle bisector, those have to be the same length, okay? So I'm not going to make up a whole nother thing here. But if I told you this was 2x and that this was 50, yada yada, you should be able to set them equal and solve, right? So then you'd say 2x equals 50, and obviously it won't be this easy on the test, and x equals 25. And then you could plug it back in if you really needed to, okay? Now, one thing you have to know is that this works both directions. So if I know that these segments are the same, or the 2x and 50 are, if those are marked as congruent, then these angles would have to be the same. And up here, if I knew that these diagonals were congruent, then these segments would have to be the same. All right? So whatever part's missing, if it's a perpendicular bisector or angle bisector, it works both directions. You can set them equal. And also, they meet at the in-center. Okay? Now, there's not going to be a whole lot about the in-center on the test. Mainly, we're going to focus on circumcenter and the centroid, which is next, the centroid. All right, so for centroid, there's kind of a lot going on here. So for centroid, you need to know that it's where the medians meet, all right? Meaning that when you'll be asked to draw it on a graph, okay? So you're going to need to graph a triangle and the medians to find the centroid. Okay, so I'm not going to do that here. Basically, there's one on the review. Let me find what one that is. It'd be on the 6.3. Be problems 3 and 4. So know how to do those. And I mean, basically everything on the review you should know, but that's just the ones I'm pointing out that I'm not going to do one up here, just for sake of time. All right, so make sure you know how to graph it. Remember, for the medians, it's just the midpoint, right? So this is going to be compared to this, which kind of leads us into, right? If you knew that 6, this length right here is 6, then RV would have to also equal 6, because this is a midpoint. And then RW, the full length, would have to equal 12. All right. Now you also need to know the ratio of the segments for each median, right? So let's look at this one here. Actually, well, yeah, let's do that. So let's say if, turn my phone on silent. If we say that, I don't know, what should we say? Let's say that SV equals 5. Okay, so if this right here is 5, then we should be able to say what ST and TV are. Let me say this differently. So then ST would have to be, so okay, let's remember our ratios. So maybe I'll write this over here. So the ratio, gosh, I'm drawing a brain fart here. Okay, so the median is split. So one part is double the other. Okay, so if I say that SV is 5, well then the other part is double that, so then ST has to be 10, and then you can say that the whole thing, VT, has to be 15, okay? So then you could also fill in that, okay, if this is 4, that's the bigger part, well, then SU would have to equal 2, and the whole thing, RU, would have to equal 6. Okay, we should add them together. All right, but a more difficult one, all right, so that's kind of just cutting it in half and then adding it together. A more difficult one would be if they gave you something like, let's say if, what haven't we used yet? Okay, let's say QW. If QW equals, I don't know, let's say something like 24. Yeah, that's a good one. If QW equals 24, then you need to find the other two. So this whole thing is 24. If this is double this, what two numbers would give us 24? You can guess and check that, but there is a 2/3 rule you can use, or you can just cut it into thirds. Then what would QS equal, and what would SW equal? All right, so if you're stuck on one like this, split it into thirds. So we can split 24 into thirds. So why don't we do 24 divided by 3, and we get 8. And that should be a good starting point. Okay, with 8, that's going to be our smaller one. We can double check. So QS would be 8, and that would make the other one double, which would be 16. And now we check, will that add up to 24? Okay, 8 and 16 make 24. That checks out, okay? They call it the 2/3 rule because this is 2/3 of 24, but really you're just going to divide by 3 and see what fits. All right, so just make sure one part is double than the other, and yeah, so there'll be a lot of those type of questions, or that'll be a big chunk of the test, but not too bad if you know the double rule, and then if the whole thing, just divide it into 3. Okay, circumcenter. What was I going to say here? Let me just look. Okay, so I already talked about what the circumcenter is, and that you will have to graph it. What did I want to say here? So I thought I already said that. No, I didn't say that. I said you have to graph the centroid. Okay, so for the circumcenter, you will have to graph a triangle. You're going to have to find the perpendicular bisectors. And the circumcenters where they cross. Now, I'm not going to make it difficult because I'm going to give you a right triangle. So for a right triangle, they will cross on the triangle, which will make your job a lot easier. So I'll just tell you, I'll give you a right triangle. All right, so that's kind of like on the front page 4 and 5 of the review, 6.2, 4 and 5. Yeah, just like that. Those are both right triangles. So that'd be some good problems to practice there. Okay, so this is going to be on the test. This next part is just for Geometry A. If you're in Geometry B, it's going to be an extra credit question. It'll still be on there, but it'll just be extra credit. All right, so you're going to need to write the equation of a perpendicular bisector. So you'll be given a segment, you have to cut it in half and write the equation. So okay, you're going to have to do a couple things. So first, you're going to have to find the midpoint. Okay, and it's just halfway between them. So you can just add them together, divide by 2. So let's look at this example here. We want to find the midpoint between these two to start. So think of it like this. We've got a segment. We want to cut it in half at a right angle. Okay, so we first need to find this midpoint as our start. So halfway between -5 and 3. So we can just add them together, divide by 2. So -3 and 5, sorry. So we can do -3 plus 5 over 2. That'd be 2 divided by 2, which would just be 1. And then halfway between 1 and -1 is just going to be 0. So our midpoint is going to be 1, 0. Okay? Next, we need to find our slope between these. So you can use a graph to do this. You don't need to because we can find the slope just from these points. So I would do y2 minus y1 over x2 minus x1. -1 minus 1 is -2. 5 plus 3 is 8. We get -1/4. Now, in order to find our perpendicular, we're not going to use -4. We're not going to use -1/4. We're going to do the perpendicular slope, which would be this, but the opposite reciprocal. So we flip it, change the sign, and we get our perpendicular slope is 4 over 1, or just 4. All right, now we put it all together. We're going to plug it into this bad boy here. Y equals y minus y1 equals m times x minus x1. So I would definitely put this on your note sheet, this equation here. So we plug in our midpoint, which was, I think, 0, 1. No, 1, 0. So it'll be y minus 0. And this will be 4, x minus 1. And we get y equals, distribute 4x minus 4. And we have our answer. Let me make sure I'm not missing anything here. Okay. Yeah, there will be a little bit of difference as far as like extra credit between Geometry A and Geometry B, but for the most part, it'll be pretty similar. And if you know this stuff, you should be good. You get a note sheet front and back, and that's it. Okay. Make sure you know that stuff and you come prepared. Adios.